Algebra 2, Chapter 2, Section 6, we're going to talk about scatter plots, what type of correlation scatter plots can have, positive and negative correlation, and exactly what a best fit line is. So a scatter plot, I'm going to show you the definition. Here is a word from the word wall, scatter plot. A scatter plot is a graph of a set of data pairs, x1 and y1, x2, y2, all the way to xn, yn for the amount of data points you have, n data points. It's really a bunch of ordered pairs, and it's the graphing of all these ordered pairs on a coordinate plane. So I'll show you an example of a real rough sketch of a scatter plot. Here is a coordinate plane, like so. This is the vertical and horizontal axis. So here's x, here's y, and a scatter plot is like a scattering of data points across the coordinate plane. Okay? Now, here is an example of a scatter plot. I just made one up. This is what a scatter plot looks like. It looks like a bunch of data points on a coordinate plane. Now, scatter plots can have different types of correlation. So I'm going to show you these definitions now. Okay? One type of correlation is positive correlation. Okay, positive correlation is if y tends to increase as x increases. So if you examine a scatter plot and you see that y tends to increase as x increases, that can be a scatter plot that shows positive correlation between two kind of quantities. So here's an example of a scatter plot. It's a real rough sketch that has positive correlation, something that looks like this. Something that looks like that. If I kind of wanted to say, hey, you know what, these dots sort of follow this line, or this pencil looks like a line that has a positive slope, therefore this one is a positive correlation. So this one is an example of positive correlation. Okay, now on the flip side, we're going to quickly draw my axis, my coordinate plane, x and y. We're going to talk about negative correlation. Okay, on the flip side, negative correlation. Negative correlation, if y tends to decrease as x increases. So here is an example of a scatter plot that has negative correlation. Something that looks like this. Now, this one is a scatter plot with negative correlation because if I drew a line, let's say it's my pencil, and it kind of went through all the points, it looks like a line with a negative slope. So this one is negative correlation. And the first scatter plot I drew up here, there's no really kind of way I can draw a line on this thing. So I mean, this is what we call no correlation, or I can't tell the correlation easily by examining the scatter plot. What we're going to talk about now is what a best fitting line is. A best fitting line is the line that lies as close as possible to all the data points in the scatter plot. So if I wanted to take a ruler and I wanted to draw a line, let's say through the positive correlation one up here, this would be, I think, an acceptable line for a best fitting line. This best fitting line sort of lies between all the data points, and it's really close. I could have maybe tilted it up just a little bit, but this one is what we call the best fit line. And again, if I was going to draw one for the negative correlation, we would draw this one, something like that. It would be the best fit line for a negative correlation scatter plot. I'm going to make a quick scatter plot right now with this right here. Okay, usually they're giving you a table. Okay, this table represents data points with an x variable and a y variable, and we can plot those. Let's say this one's a first quadrant coordinate plane, x, y, vertical axis y, horizontal axis x, and I'm going to consider these to be points, and I'm just going to quickly, as fast as I can, plot these points. So 1, 2, 3, 5, 1, 1, 3, 4, 2, 2, 2, 3, 4, 6, 4, 7, 1, 0, 3, 3, 4, 5. Okay, there is a scatter plot. Okay, I had a bunch of data points. This is my data points, and I plotted them on a coordinate plane. Looking at the scatter plot, I can say, hey, you know what? This looks like it has some kind of correlation. This correlation that I'm looking at looks like it's positive correlation. And relation. Sorry, it's hard for me to spell early in the morning. And if I wanted to draw a best fit line, I want to draw a line that lies as close as possible to all the data points. I would say, something that looks like that right there. Okay? Now, there's something else you can do. You can actually write the equation of this best fit line. And what I'm going to do is I'm going to show you how to do that down here. I drew a best fit line. This line lies pretty close to all the data points. It looks like it has a positive slope, and I can actually calculate the slopes. Notice how this line actually goes through 1, 1, and it goes through 4, 6. Okay? Slope of this line could be, and I use the slope formula, y2 minus y1 over x2 minus x1. And I'll say this is my x1, y1, and this point represents my x2, y2. And I'm going to, so y2 is 6 minus 1, y1 was 1, x2 is 4 minus x1, which is 1. I get 5 over 3. So I get a slope of 5 over 3. Okay, and then if I wanted to write the equation of the line, what I would do is substitute this slope into, let's say, y equals mx plus b, the slope-intercept form for a linear equation, and I'll use one of the data points. So I'll use actually 1, 1. Y is equal to 1, so I'm going to substitute y with 1. M is equal to 5/3, and x is equal to 1 plus b. Okay, 5/3 plus 1. So if I wanted to solve for b, what I would do is subtract 5/3 from both sides of the equal sign. And I'm running out of room here, but 1 minus 5/3 is actually negative 2/3. And that's what b is equal to, so negative 2/3. And I can say that the equation of this line is y equals m 5/3 x b minus b, or plus b, which is negative 2/3, so it's minus b minus 2/3. Okay? And that would be writing the equation of a best fit line. Okay, this video went a little long, and I'm going to stop.